Today we're getting those multi-step equations with variables on both sides of the equal sign. It gets a little wild, but our first step is always the same. Distribute, and then you combine what you can on the same side. So after step 2, you should at most have 2 terms on either side. So the new step is we got to get those variables on the same side. So it says to move the variable with the smaller coefficient to the other side, the smaller number out in front. Now, that is not essential. You could move the larger one, but then you're just dealing with negative numbers, and that's fine. We should be comfortable with negative numbers. So you don't always have to move the smaller one. I usually like doing it because then you're dealing with positive numbers. And then you do your normal like undo addition and subtraction, undo multiplication and division. So you do the inverse operations from there. So let's try it out. We have a couple here. 6x minus 9x minus 4 equals negative 2x minus 2. Now again, some people like putting the line down the equal sign, and they're like, if I'm going to add or subtract something to the left side, I have to also do it to the right side to keep it balanced. But initially, all I'm doing is combining my like terms on the left side. So I'm not changing the equation, I'm just kind of cleaning it up over here. So I could do the like terms, 6x minus 9x. If they're on the same side, you just do what it says. 6 minus 9 is negative 3. So we have negative 3x minus 4 equals negative 2x minus 2. So we've distributed, there was nothing to distribute. We've combined everything we can on the same side. Here's our new step. We have to get the variables on the same side. So the notes right before this said to get rid of the smaller coefficient. Again, not necessary, but it is the way I like to do it. So the smaller coefficient is negative 3. What's the opposite of negative 3? Positive 3. That's it. So you're either adding or subtracting to move it to the other side. So we're going to add 3 x's to both sides of the equal sign. Because negative 3x plus 3x is 0x. These cancel out. So all we have left on the left side is negative 4 equals negative 2x plus 3x is positive 1x. You could write 1x, or you could just write x, and then you got your minus 2. That's all you have left. Negative 4 equals x minus 2. There's one step. You just got to get rid of the minus 2. So we're going to add 2 to both sides. Negative 4 plus 2 is negative 2. Negative 2 equals x. That's it. Now, it's good to check in the original equation if you have that extra time. So like 6 times negative 2 minus 9 times negative 2 minus 4 equals negative 2 times negative 2 minus 2. So 6 times negative 2 is negative 12. Negative 9 times negative 2 is positive 18. Negative 2 times negative 2 is 4 minus 2. Negative 12 plus 18 is 6. 6 minus 4. 4 minus 2 is 2. 6 minus 4 is 2. Ha! We did it! We did it! Let's look at example 2. I'll go ahead and throw the line down the middle. Again, that is an optional step if you'd like. Is there something to distribute? Yeah, dude. We got to distribute this too. 2 times 6 is 12. And 2 times negative 4d is negative 8d equals 25 minus 9d. Is there anything on the left side to combine? No. Can you combine anything on the right side? No. So now let's get the variables on the same side. What's smaller, negative 8 or negative 9? Negative 9 is smaller. So that's what I would get rid of. I would add 9d to both sides. When you're canceling out a negative, add it. If you're canceling out a positive, subtract it. So left side will bring down our 12. Negative 8d plus 9d is 1d, so plus d equals, over here we just have 25. So 12 plus d equals 25. How are we going to get rid of the 12? It's positive. It's out in front. So let's just go ahead and subtract 12, because 12 minus 12 is 0. d equals 25 minus 12 is 13. Probably a good idea to check it in the original. So let's see, 2 times 6 minus 4d equals 25 minus 9d. Whoa, these got some big numbers here. So 2 times 6 minus 4 times 13 is 52. 25 minus 9 times 13, I think, is 117. 2 times negative 46 equals 92? Negative 92. And then 2 times negative 46 is negative 92, so we're all good. That was a tough one to check. It was harder to check it than to actually do the problem. That's wild. All right. Cool, let's keep it moving. We got some special stuff here. When you solve x will be equal to a blank. What? What? So, a number, a solution. So you'll get something like x equals 5, or example, x equals 5, or x equals negative 2/3, right? It comes out to just one solution. So if you look at the example here, negative 8c plus 21 equals 2c plus 1. If we were solving this, we would add 8c's to both sides. So we'd have 21 equals 10c plus 1. We're going to get rid of the plus 1 by subtracting 1. 20 equals 10c, and then you would divide both sides by the 10, and you get 2 equals c. So you just get one solution like that. That's pretty typical. That's what happens most of the time. Now on the second example, this is kind of like where it could get a little weird. When you solve, the x terms will cancel out. So, no value for x will ever work. The last step will show a constant equal to a different constant. And you're like, what are you talking about, Mr. Plant? All the x's will go away, and you'll just be left with something that is like 4 equals negative 1. That's all that's going to be left. Does 4 equal negative 1? No. So this would be considered a no solution type of problem. It does happen from time to time. It gets pretty wild. So if you look at this example down here, if we were solving this, we would subtract 2 x's from both sides. These would cancel, so you'd have 7 equals 9, and then these would cancel. 7 does not equal 9, so that would be no solution. There is no number that you can put in for x to make that true. Now, there is another strange one. So, this one is kind of similar. You solve, and the x's cancel out. But this one's different because any value for x will work. The last step will show a constant equal to the same constant. So again, all the x's will cancel out, and you'll be left with something like negative 5 equals negative 5. And what we say for that is IMS, which stands for infinitely many solutions. Or another thing you could say is all real numbers. That's probably more common at this point in the year. Later when we get to systems of equations, we're going to say IMS. But for now, let's say all real numbers, meaning you could put in any number for x and it works. You could put in 50, it works. You could put in negative 2.186 and it works. So let's look at this example here. 4y minus 10 equals, if we distribute, this would be 4y minus 10. Now, they look identical, so sometimes this is also referred to as an identity. So if we were to subtract 4 y's from both sides, we'd have negative 10 equals negative 10. all the y's cancel out. So again, these are like special circumstances where this happens. 90% of your problems, you're going to get a solution. But if all the variables cancel out and you're left with something not true, it's no solution. If you're left with something that is true, you could just say all real numbers. X equals all real numbers. Again, these are kind of rare. But we're going to try out some word problems now and see how we do. So we're going to do one together, and then I want you to try one. So setting it up is the tough spot. There are 2 gym packages. The first is $50 a year for a membership plus $5 per visit. The second is $200 for the membership fee and $2 per visit. Which is better? Well, it depends how many times you go, first of all. But let's see when it's going to be the same amount. So we're going to set them equal to each other. Now, if I go to the first plan, it's $50 per year. Now, I only have to pay that once per year. So I'm going to say 50 plus, it is $5 per visit. So if I went 3 times, I'd have to do the 5 times 3, which is $15, and then I would add the 50. So that per, we're going to do multiplication. So we're going to say 50 plus 5v equals, and the other one is $200 per year. Doesn't matter how many times you visit, but you do pay $2 per visit. So it's cheaper per visit, but you do have the higher fee. So let's go ahead and solve this. There's nothing to distribute. If we were to get the variables on the same side, I would get rid of the smaller one, the 2v. So I'm going to subtract 2v from both sides, which would give us 50 plus 3v equals 200. And then we could get rid of the 50 by subtracting it. 3v equals 150. And then that's 3 times v, so we can divide both sides by 3. And we get v equals 50. Now v was the number of visits. So 50 visits. Now, they're asking which is better. And we got the answer, 50 visits. That doesn't make sense with what they're asking. But what we did is we figured out if we go 50 times, if we visit 50 times, they're going to be exactly the same. So if it's asking which one's better, it kind of depends. If we go less than 50 times, then it's going to be cheaper to do the $50 plus the $5 per visit. So the $2 one, it's cheaper per visit, but you have that higher initial fee. So if we go a lot, then that's going to be the better deal. But if we're going less than 50 times, less than 50 visits, then the $50 plan is better. If we go more than 50 times, the $200 plan is better. Because then we're only paying that $2 each time that we go. If we go 50 times, they're the exact same. It doesn't matter. But anything more than 50, the $200 plus the $2 is better. Any less than 50, the $50 plus $5 each time is better. So I have one for you to try now. Feel free to pause, see if you can even set it up together. Otherwise, we'll set it up right now. Games R Us charges $50 a year for a membership fee and $3 for each video game you rent. Gaming Rental charges $8 a video. Which place would you rent from? So if we were setting up an equation, the first place is $50 a year plus we have to do $3 for each video game. We're going to set that equal to the other place, which is just $8 per video game. You don't have to pay the membership fee, so it's just 8V. This is when they're going to be the exact same cost. So if we subtract 3V from both sides, we have 50 equals 5V. Divide by 5, and you get 10 for V. Okay, so if we're going to get 10 video games, they're going to be the exact same thing. But if I get 11, then we're going to go, like, when we see each, we're going to go with the lowest each. So, like, if I go more than 10 games, the $50 plus 3V, the Games R Us is better. Whoops. Games R Us is better. Now, mathematically, if we wanted to check that, we're getting 10 video games, it's the same price. So how much would that cost? If we did 10 games, the second place, the rental place, is $8 times each of those. So it would be $80. In theory, the other place should also be $80. Games R Us would be 50 plus 3 times the video games. 3 times 10 is 30 plus 50 is also 80. So if we get 10 games, it's going to be exactly $80. But as soon as we go 11 games, the one that's the rental incorporated is $8 each. So that would be 8 times 11. That would be $88 for Games Incorporated. But the other one would be 50 plus 3 times 11, which is 50 plus 33, which is 83. So if you're going over 10 games, then Games R Us would be better. If you're going less than 10 games, then Rental Incorporated would be better for you. So that's kind of the tough spot, because it just depends. Are you going over 10 or under 10?